Welcome to Activity 2.2 out of our book, Systems and Contact Forces. So we are on page 12 of the book. Our learning target today is we're going to analyze some scenarios to figure out what forces are acting between the components. And I will complete the models and answers for Activity 2.2. Again, we should be on pages 12, and then you'll finish up page 13. So before we begin, let's review a little bit. What have you learned about scientists, or what have you learned about how scientists talk about systems? So we've talked about systems in our last book. What makes something a system? Well, each of the four devices in Activity 2.1 can be called a system because it's composed of multiple components. So if you go back to the magnetic cannon, you had different components. You had the steel balls, you had the track that it was on, you had the magnets. All those are different components. You put all the components together, it's considered to be a system. The air-powered car, the tape to hold the car and the fan together, and the fan would all be considered part of the system, and the table as well would be part of that system. So what you're going to do is you're going to analyze a different system and then apply what you've learned to the devices in Activity 2.1. So I've got a scenario for you today. Consider these two vehicles. They're trying to pull one another. Say one got stuck in the mud, and it looks like this is the one that's stuck in the mud. So, first of all, what are the components of the system that influence its motion? And this is pretty big, because if you have to be able to pick out the components to do what we're going to be doing in today's lesson. So there's the two vehicles, there's the rope that's connecting them, and then there's the ground or mud, and then the planet Earth. And we're going to, whenever we think of the Earth and these diagrams that we're going to draw, we're going to think of the Earth as just being the source of gravity. So that's why we always put the Earth. That's because there's going to be gravity. So let's get started. First of all, draw a simple model of the two vehicles and the rope connecting them. So draw a simple model of the system with rectangles representing the components next to each other. So go ahead, pause the video and do this. Now, you've had a chance to draw it. What I'm going to do, normally I don't take you through all the answers, but in this case I am, because this is pretty important, because if you know this information, things later on in the book will come in handy. So first of all, what are all the components? We already went through those. So here's the vehicle, here's the rope, and here's vehicle 2. We have the ground there on the ground, and here's the Earth. Now remember, the Earth basically just represents gravity. So in the last video I said, or for 2.1, I said, we didn't have the ground, we just had the Earth. Well, you could have included the floor there, so I kind of misspoke. But when we think of the Earth, you think of the ground, you think, well, they're the same thing. Why do I have to put them both? Whenever we think of the Earth, we're thinking of gravity. And the ground is what these are on, and then this is going to be applying the gravitational force. So make sure your model looks like this. Now, number 2 says, which components of this system interact with each other? Now, this is what we're going to do for this. We're going to create an interaction table. So go ahead, draw what you see right here in your book for number 2. So instead of answering this question, which components of this system interact with each other, and instead of going through every single one, we're going to make a quick table, and then we're going to put pluses, and we're going to put minuses in the ones based on how they interact. So this is going to be a lot faster. Otherwise, you're going to have a good sized paragraph for this. Now remember, a force that is the result of two objects touching each other is called a contact force. So what we're going to do, we're going to put a plus in the box for components that interact with each other, and a minus in the box where components do not interact. So the way this works is I look here at a vehicle, and I just go down. So does the vehicle number 1 interact with the rope? Absolutely. Does vehicle number 1 interact with vehicle number 2? Well, do they actually touch each other? No. Vehicle number 1 actually touches the rope. Now, does vehicle number 1 interact with the ground? Yes. And does it interact with the Earth? Now, this is where it gets a little tricky. Remember, Earth always represents gravity, so yes, it does. So I'm going to take a minus and put it in here, because vehicle number 1 did not touch vehicle number 2. So let's go through this one. Now, does the rope interact with vehicle number 1? You might say, Mr. Toon, you just already asked me that question. Yeah, I did. So we know that the rope already interacted with vehicle number 1 from right up here. Now there's a slash through this one because the rope can't interact with the rope itself. Now, Did the rope interact with vehicle 2? We haven't answered that question yet. We just said, did the rope interact with vehicle number 1? So that's definitely a plus. The rope is connected to vehicle number 2. Is the rope interacting with the ground? Well, we haven't answered that question yet. It should be if it's actually pulling each other out. Now, if the cars aren't, or the trucks or whatever is being pulled out, if the vehicles aren't far enough apart, maybe the rope would be touching the ground. But in this case, we don't have to worry about it. Now, is the rope in contact with the earth again? Think of the earth as being gravity. So yes, gravity is pulling down. Gravity pulls down everything. Now, vehicle number 2, is it in contact with vehicle number 1? We already answered, grabbed the wrong one. We already answered that question up here. How about vehicle number 2 in contact with the rope? We already answered that question, and it was yes. How about vehicle number 2 in the ground? We haven't answered that one yet. It is, and then we also know that vehicle number 2 is subjected to gravity. So how about the ground and vehicle number 1? Yep, we already answered that one. Way up here. How about the ground and the rope? We already answered that question. No. How about the ground and vehicle 2? We already answered that one. So you see, once you get through the first half, this actually goes pretty easy. So if I look here, they're all plus. That means these are all going to be plus. You might say, well, why the redundancy? Well, it's really the only way you can get to see how they interact, because where these boxes intersect is where the interactions take place. So if you just had these and it was going down, how do you know what it interacts over here? So again, once you get the first half done, the second half is really easy. So again, this is called an interaction table. So let's start going through the questions. Question number 3 says, when people push each other, is there one force acting or two? So what do you think? 2 people pushing each other's hands? Well, if you push one way, they're pushing the other way. Absolutely. So when people push each other, is there one force or 2? There's definitely 2. How many forces does each person apply? Each person applies their own force, so they each apply one force. So let's look at the next question, number 5. How many forces act on each person? Well, it's down here at the very bottom. I can't get any lower. You can see it right down here. It is 1. So let's go to the ladder. So how many forces, or when you sit in, hold on a second, let me get there. Here we are. So when you sit in your chair, do you push down on it? Yes. Does your chair push up on you? Yes, we talked about this in our last one, or at the beginning of this one. Can you think of an example when contact forces are not paired? Can you think of any time where you don't have a push and a pull? Or, one person pushing one way, one person pushing the other way? Well, there's no such examples. Forces always come in pairs. So if we back up a little bit, this ladder's pushing on a wall. What's the water doing? What's the wall, sorry, not water. What's the wall doing to the ladder? It's pushing back. You pushing the wall. What does the wall do? It pushes back. So when you have a shoe and you're pushing on the floor, this is kind of a tricky thing to understand. The shoe pushes on the floor, you push on the floor is actually pushing back. And think about it this way, if you pushed on the floor and the floor didn't push back, wouldn't the floor be moving? You might say, okay, how about air? If I push on air, isn't the air doesn't push back? Well, it does. It's just that you're applying a greater force. So forces always come in pairs. So let's look at question 9. Return to your model you drew of the 2 vehicles and rope. Add pairs of forces to your model. So earlier you drew this. Now what we're going to do is we're going to add forces. So go ahead, pause the video and add forces. Now you've had a chance to add forces, do they look like this? Where the vehicle is pushing on the ground's pushing back. And then you had the rope pulling on the vehicle, and the vehicle's pulling on the rope, and vice versa for the other vehicle. It would be the same. Now you might say, how about the earth? And we haven't gotten to the earth. The earth, these are all contact forces, forces that are in contact with each other. But when we talk about the earth, we're going to be talking about gravity and non-contact forces, or forces that act at a distance. So what can you conclude about pairs of forces, pushes and pulls, and a direction of forces. Let's go ahead and pause the video and answer that question. So what did you come up with? Well, we know that contact forces always come in pairs and in opposite directions. All contact forces, pushes or pulls, come in pairs. If one force is a push, then the other one will be a push as well. If one is a pull, the other will also be a pull. And this means that the pairs always act in opposite directions. So think about it. If you push something, it's got to be pushing back. That's how you don't move. So you push in your chair pushes back. If you were pushing on your chair and your chair was pulling on you, you'd be going in one direction. So it can't happen. So things have to push back. Things have to move in pairs. So this is kind of a hard concept, and we're going to continue to cover this in the entire book. So again, we're just in Activity 2.2, and we'll continue to cover this. So as always, if you get done with this video, you have any questions you just have to ask, or you don't understand something, you want to talk about it more, make sure you stop in. I'd be happy to talk with you about it. Thanks.